Alright, chapter 7. We're headed into hopefully what a lot of you can call familiar territory. In chapter 7, what we are going to be focusing on are exponential functions. And as you can see in the objectives, it's a lot of review. So, chapter 7 is really nothing that we have not well, we've learned everything in Chapter 7 before, and really what we need to do is review. Some of the main things that we're going to be looking over is graphing. How do you graph exponential functions? And eventually we're going to be looking at how you graph logarithms. Transformations of functions is something that we have to review because exponential functions are no different from quadratics or absolute values or cubics, where they take on certain forms of shifts and stretches. So how do you cue someone in and how to stretch, shift, or shrink a graph or flip a graph? These patterns are all the same, and we're going to see that with exponential functions. Some of the key vocabulary that we need to look at is, first of all, what is a power? A power is just going to be some sort of base raised to an exponent. Remember, we have a base and then an exponent, and yeah, that's a power. When we're looking at powers, if we write that into an exponent or into a function form, so we take on that f of x, labeling it, stamping it that it's going to be a function. So for every x, there's only one y value. What we're saying here is that basically we're looking at a value raised to a variable exponent, especially a function where the value is e. This is from Google. So here we just have it in function form. Alright, so now that we know that it's a function, we can go ahead and graph it. And if you're ever confused about how to graph, don't forget we always have our x, y tables. So I'm going to go ahead and do that right down here. The best ones to do for these basic exponential functions where you have a base to our variable, what I'm going to just do is that negative, let's say negative 2, negative. Okay, so basic properties here, if you have 2 to the negative 2, that's, I hope you guys have gotten quite a bit of practice with this now. We can cross the line, change the sign, so this is going to go down to the bottom. We can have it as a positive power, so it's going to be 1/4. This one's going to be 1/2. This is going to be 1. We're going to review some of these properties in a little bit, but remember, anything to the 0 power is always 1. 2 to the 1 would just be 2 here, and then 2 to the 2, of course, is 4. So I'm going to go ahead and graph these. Okay, so our very first point that I'm going to graph is negative 2 and then 1/4. So I'm sitting at something right about there. Negative 1, 1/2. So, and then this, of course, is going to exponentially grow pretty quickly. So I have a graph. Oh, whoops. That looks something like this. Alright, what I do want us to just kind of take into account here, when a is greater than 1, what we're going to have is an exponential growth. So 1.2, 1.5, 2, 5, anything greater than 1 is always going to be exhibiting this kind of shape. A domain here, remember domain are all possible x values. This could be anything. We could plug in any real number for our x because that's in our control here. From negative infinity to infinity we could plug in. So I'm going to go ahead and write that right here. And all of these are on page 459. Range, this is a big thing. Range, understand that that's all the y values. There's nothing that I could put in for this x that would ever make this a negative number. Alright, I could put in the largest negative number that I could possibly think of here, but it's still, if I put in negative 2 million, it'd still be, when you flip that over, 1 over 2 to the 2 million. Alright, but because this one is on the top, you're always going to have some sort of number that's approaching 0 but never getting close to it, or never touching it. So what we have really for this range is going to be 0, and this is a roundy brackets because we're not going to include it, up until infinity. Y-intercepts, think about it this way. For a very standard exponential function, the y-intercept is, keep in mind when x is equal to 0, so when x is equal to 0, when this exponent is equal to 0, we're going to get 1. So when x is 0, y is 1. Okay, always for a very basic exponential function. And then end behaviors, this is what I want to take into account. There is what we call, as you go towards the left, so as x approaches negative infinity, what's happening here that we should recognize is we have this horizontal asymptote. It's true that this right hand side does not ever approach it, but we do have for the left hand side a horizontal asymptote that is equal to y equals 0. Alright, so those can all be found on page 459. Just kind of consider these and kind of consider why it is the way it is. Alright, so with that, this is a very, very basic exponential function. 2 is as low as it gets really without getting any decimal numbers. We couldn't have 1, of course, because 1 to any power is just going to be a constant 1. So when we do go back here, let me just quickly flash that. When we did have that definition here, keep in mind that b has to be a constant greater than 0 but not equal to 1, and you can consider why that would be the case. So now that we graphed that basic function, what I would like us to look at are these basic parent transformations. So remember in the past, if any time you add something or subtract something not within the parentheses around the x, or not directly attached to the x, that's a shift up or down. Alright, and it's exactly what you would think. If you ever have something directly attached, added, or subtracted onto the x, that's going to be what we call a horizontal. Remember, x is everything to do with horizontal. It's going to be going left or right in the opposite direction of what you would think. So you can see here, if you add something onto x, you would think, oh, I'm adding something horizontally, so it's going to go right. But no, it actually goes left. So keep in mind with those. If ever your overall function is negated, so it's not directly attached to the x, there's a negation attached to the whole entire function, it's flipped. Once again, since it's not x, we're talking that's not horizontal, so it's vertical. It would be flipped upside down, reflected over the x-axis, or reflected downward or upwards. If it is attached to the x, that's when we're going to have a negation horizontally, so it's going to be reflected side to side. So these are reflections. Flips or reflections is what you can call it. Alright, so we're going to do example number 13, just to kind of get you into this idea of how we shift these exponential functions. So here I went ahead in blue and I drew the 2 to the x, so our power to the x. And now what I'm going to go ahead and do is graph this transformed one. And what actually 13 only asks you to do is notice, alright, we have this negation. It's not directly attached to the x, so we're just going to have a vertical flip. Because remember, negations would suggest a flip. Or reflection. It's up to you what you call it. I normally just call it flips. So that's actually all 13 asks you. That's done. But what I would just like to show you is this graph. Since it's a vertical flip, this is what we would have to do. It's like you would take a grip on this arrow here and pull it downward. But because it's vertical, it has to do with everything to do with y's. So all of these y values are actually going to be negated. So this was 2 up 4. Instead now it's going to go 2 down 4. This one was over 1 up 2. It's going to be over 1 down 2. This one was over 1 up 1. Down 1. So everything about this has flipped vertically, and it's going to look something like this. But really, once again, all this was asking you to do was name the transformation due to what was indicated in the equation. Alright, another example. And so now 47 actually does ask you to graph these. So when you're looking at this overall function, this is the most basic. You see this 3 to what is our variable? Well, it's x. So this is our most basic exponential with one singular value to a variable x. I'm going to go ahead in blue and I'm going to do this as -2. This is my horizontal shift. So the horizontal shift would take all of these and do the opposite of what you think. Shift all of my points of my original function over 2. And then what I'm going to do with all of these points, not only do we take these points and move them over to the right 2, but we also move them up. So I am going to do that one in purple. So all of these points are going to go up. And I also want you to keep in mind that we had a horizontal asymptote here. That is going to be shifted up as well. Sorry, so this is right there. So that is going to be shifted up to this y equals 1 line instead. So now as we graph this, as we graph this, this is what it's going to look like. Go through our key points that we've just kind of graphed for ourselves. There we have it, we're done. Alright, this is number 39. It's a look at what if your b is less than 1. So what it looks like, I'm going to go ahead and just plug in these points just like usual. If you're ever in doubt, this is what you would do. Plug in these points. So I have 1/5 to the -1. So keep in mind, and once again, I should have gone over these properties earlier, but we're going to go over them in a little bit. If you ever have a quotient and it's all up to a power, you can distribute it. So it's going to be 1 to the -1 over 5 to the -1. And now these, cross the line, change the sign on both of these, it's just going to become 5 to the 1 over 1. So this right here is 5. Okay. Once again, anything to the 0 power is just 1. 1/5 to the 1 would be 1/5. And then here, this final one that I have plotted, or I'm trying to plot here, this would be distributed 1 squared and then 5 squared, so it's going to be 1/25. So what you can see is this whole thing has kind of reversed. As we increase with our or as we decrease really and go towards higher negative numbers or lower negative numbers, this thing, for example, would be 25 if we plugged in -2, because it would distribute that -2, and then we would have to flip it. So I'm going to go ahead, we're going to label all of these by 1s. And I can't really reach that 25, but I am going to go ahead and do the -1, 5. We have that 0, 1. We have 1, 1/5. And then we also have 2, which is associated with 1/25. Oops. So it's something located right about, oh my goodness, right about here. So it's getting closer and closer. So what this is actually an exponential decay function. And that's what happens when we have a base that is less than 1. Of course, it always has to be greater than 0. Whoops, that should be increasing at a quicker rate. But there we have it. So this is the basic way that we're going to be graphing these. And if I were to now add 1, let's say, to this x directly attached to it, well then this is going to be a horizontal shift. So I take all those points and move them back 1. If I negated this whole thing, then I would negate it and then move it back 1. If I were to add 1 to this whole thing, then same thing, it's going to be a vertical shift because it's an addition not directly onto the x, so you would have to do all of these. You would have to flip it, move it back 1, move it up 1 with all of those points. So as long as you can get a few of these major points on there, then you can just start applying those shifts as they are meant to be applied. So here I have one last slide that I want to show you, which I should have shown you at the beginning. So here are some of our exponential properties. Hopefully you are recognizing these because these are a lot of the properties that you've been using just with the algebraic maneuvers that you've had to do with all this calculus work. So remember, anything to the 0 power is always 1. Here, for example, if you had 2 to the 2nd times 2 to the 5th, you can always just go ahead and add those exponents, because if you expanded that out, you'd have 2 2's there, you'd have 5 2's there. You could just go ahead and combine them all and say, oh, there's 7 2's that are being multiplied. So we've been doing a lot of work with that, with powers that are fractions. So to the well, actually, we've been doing more stuff like this. X to the 1/2 times x to the 2nd, and then we've been multiplying those powers, which meant that we were adding those exponents. So same with all of these. You are going to need to recognize all of these, so please take a moment to look over them. But other than that, this is the end of this lesson. I will be working with E in the next video.